Okay, geometry, here we go into the last section of Chapter 3. 3.8 is really the whole reason that we did 3.7. Here we're going to talk about the slopes of parallel and perpendicular lines. So we've kind of gotten off the subject just a little bit with what we've been focusing on in 3.7. 3.7 was a section where we completely did a review of material that you guys learned in algebra about what slope is, how to find slope, graphing linear equations, and writing equations of lines. That really had nothing to do with the overall theme of Chapter 3, which is dealing with parallel and perpendicular lines. But now in 3.8 we try to tie all of this together. So, a couple of big ideas right here. The first one that we're going to talk about is this concept here that parallel lines have equal slopes. I'll come back to this idea in just a moment. So this is one that people usually don't need a whole lot of convincing of being true, but if we were to take just a moment right here and talk about a couple of lines that have equal slopes, well, let's think about that. If we were in class right now, guys, I would ask you just to make up a number for me and say, hey, somebody give me a slope out there. So I'm going to pretend that I'm going to call on that person over there, and they're going to say -2/3. That's the slope that we want to talk about today. All right, so let's talk about two different lines out there that both have a slope of -2/3. Like, for example, I might go in green here and say y is equal to, if we're talking a slope of -2/3, that's my m, there's my x, and now I just need to make up a random b value like, oh, I don't know, +4. Now that's an equation in slope-intercept form, so it should be quick and easy to graph it. Our y-intercept is 4, so from the origin, I'm going to go 1, 2, 3, 4 units up, and there's my starting point. And the slope now tells me where to go from that starting point. Remember that slope is rise over run, so we're going to rise -2 units and run +3 units to come up with the next point on our line. So that means we are going to go down 2 and right, not over, right 1, 2, 3 units. And that gets me to a second point on that line. Down 2, right 3. Let me do that again. Down 2. Right 3, and I've got room to do it again, down 2, right 3, and it's never a bad idea to reverse that now. Think of it as +2 over -3. That would mean that I go up 2 and then left 3 would get me yet another collinear point. Okay, so here is one line in green that I have drawn here with a slope of -2/3 like we talked about just a moment ago. And now, if I wanted to draw a second line, that, again, using this idea that we're discussing here, that parallel lines have equal slopes, I'm going to have this second line have the same slope as the first line, -2/3. We're going to multiply that by x, and now I'm going to make up a different y-intercept. I'm going to go with a -1. So graphing this line in blue, the y-intercept of -1 means that we start from right there, and our slope of -2/3 again means that we go down 2, right 3, down 2, right 3, or I could have gone up 2, left 3, up 2, left 3, and that's probably good enough for our purposes right now. So if I go ahead and draw that line right there, the hope would be that we kind of see the main idea here, that if these two lines have the same slope, and they do, they both have a slope of -2/3, they are in fact going to be parallel to each other. And you can kind of read that almost as an if and only if, as a biconditional statement. It kind of goes in either direction. If two lines are parallel, then they're going to have the same slopes. Although I kind of illustrated it in the opposite direction. If two lines have the same slope, then that means that they are parallel to each other. Okay, so that's what's going on in this case, and I think that graph kind of illustrates that point. I said we would come back and talk about this right here real quickly, and really, this is not a statement that people have a hard time understanding. Everybody buys it. All vertical lines are parallel. So if I were going to draw one vertical line right here, and another vertical line right here, and another vertical line right here, and another one over here, nobody doubts that these vertical lines are parallel. The real question, I don't know why I didn't put arrows up there, the real question is, why is this statement even necessary? Well, if you go back to the original statement here, parallel lines have equal slopes. That is true, but what we have down here below this is actually an exception to what was written right above. And here's the reason why. If we think back to really the last big idea, well, actually the first idea and the last idea that we talked about in our 3.7 notes, think back, everybody, about what the slope of a vertical line is. In a vertical line, if you were to think about any 2 points that are located on the line, there is a rise to get, let's say, from point A to point B, but there is no run. Your rise over run would be something like 6 over 0, which is undefined. So a vertical line doesn't have a slope. And that's the key right there. A vertical line slope is undefined, and two things can't be equal if they are undefined. It's very tempting to say that the undefined slope of this line right here is equal to the undefined slope of that line. It makes some sense in our heads, but it's technically not accurate. If two things are undefined, they can't be equal to each other. And so for that reason, this second statement here becomes necessary mathematically to write, although most people, frankly, don't have a whole lot of use for it. So now what we're going to do here, guys, in the majority of our problems in 3.8 is a continuation of what we were doing at the end of 3.7, where they give you information about your line, and you're going to write the equation of that line given the information that we have here. So let's see what's going on in problem A here. We're going to find the equation of the line, and guys, I did a lousy job right here. I should have specified find the equation. Probably I should have written in slope-intercept form. Sorry about that. So find the equation in slope-intercept form of the line parallel to y equals negative 3x minus 2 that also contains the point 2, negative 3. Okay, and this is what we're working on right now. Now, I'm going to do this in a more maybe labor-intensive way than I need to just because I want to illustrate what's happening. We're trying to come up with the equation of the line, which implies that there's only one right answer here, a line that's parallel to this line right here. So I'm going to graph this line in green, even though graphing this line really isn't necessary. Our y-intercept is negative 2, that's right here, and our slope is negative 3. Which I want to think about as negative 3 over 1. So that means from this point I'm going to go down 3, right 1, and that's all the room I have for there. So I'm going to go back to the starting point and also go up 3, left 1, up 3, left 1, and I think that's pretty good. All right, guys, so here is the original line that they gave us. Y is equal to negative 3x minus 2. Now you will notice here, everybody, that this point, 2, negative 3. Let me go ahead and plot that. 2 to the right and 3 units down. So here's the point 2, negative 3. That point is not on the green line. That doesn't surprise me because if I try to sub those values in here, y is negative 3. That equals negative 3 times 2 minus 2. I don't think this works. Negative 3 equals, that's a negative 6 minus 2 makes negative 8. That obviously is a false statement right there, and that tells me what my eyes already told me, that this point is not located on this line. But let's not lose sight of what it is that we're really trying to do here. The way that this problem was written, if I go back and think about it in a little bit greater detail, it doesn't surprise me. We're looking for the equation of the line that is parallel to the green line that passes through the blue point. And back to the idea that we talked about, the parallel postulate way back in section 3.5, everybody, here's the main idea. Through any point not on a line, there is only and exactly one line that you can draw parallel to a given line. So what's important here, everybody, is this. There are an infinite number of lines parallel to the green line. For example, that one and 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 that one, and I could go on all day. There's an infinite number of lines parallel to the green line. What else could we say? There are an infinite number of lines that pass through the point 2, negative 3. Here's one, and here's one, and here's one, and here's one, and here's one. We could do that all day long. But put it all together now, guys. There is only one line that does both of those two things. Okay? There is only one line that passes through the point 2, negative 3 and is also parallel to the green line. And that's what we need to try to find. So let me get rid of all of this junk right here, and let's kind of focus on what's going on. We need to come up with the equation of the one line that passes through this point that's parallel to the green line. Well, back to where we were at the end of 3.7, everybody, there are two things that we need to know about a line. We need to know a point that it passes through, and we need to know its slope. And in a way, we can figure all of this out. Okay, what do we know, guys? Well, in this particular green line, we know that the slope here is -3. Therefore, and this is kind of the way I'd like you guys to write this out, the slope of a line parallel to that green line is going to be, well, let's go back and read this idea again right here. Parallel lines have equal slopes. So if the slope of the green line is -3, the slope of a blue, let me do that in blue, the slope of a line parallel to that is going to be -3 as well. That's what we mean by having equal slopes. So for the blue line that we're about to create, we know that its slope has to be -3. And we know that it has to contain this point right here of 2, -3. And now, everybody, that we know, let's think about this, now that we know a point and now that we know the slope of this line, guess what form we're going to write our equation in? Point, slope, form. Say the words out loud, everybody, and it will start to make sense in your head. If you know a point and you know the slope, we're going to go to point, slope, form. That's not where we're going to end, but it's where we're going to start. So point, slope, form, hopefully we've got this down now, is y minus y sub 1 equals m times the quantity x minus x sub 1. So now let's fill in what we know. Y minus the y coordinate of our point, right there, which is -3. Minus -3 becomes a +3. Equals, our slope is -3, and in parentheses, it's x minus the x coordinate of our point, which is 2. So there's your equation in point-slope form. Now we're going to go ahead and simply solve this thing for y to get it into slope-intercept. So I'll distribute that -3 and get y plus 3 is equal to a -3x plus 6. We will subtract a 3 from both sides here and get our answer of y equals -3x plus 3. That should be the answer, everybody, and in most cases that's where we're going to quit. But for now, because it's our first problem, I actually want to graph this one with you and see if it does the two things that we needed it to do. Y equals -3x plus 3. Our y-intercept is +3, so we go up 3 and make a dot there. And now our slope, again, is -3 over 1. So we're going to go down 3, right 1. Down 3, right 1. Oh, and that's really important right there, guys. We hit the point 2, -3 directly. I guess I got room to do it again. Down 3, right 1, or I could have gone up 3, left 1. Okay, so as I draw the one and only line now, everybody, that passes through those blue dots looking something like this, let's see if we've got this right. I'm going to go back to the original problem and I'm going to read this again. We were supposed to find the equation in slope-intercept form of the line parallel to y equals -3x minus 2 and containing the point 2, -3. So you need to make sure your blue line does two things. Number one, is it parallel to the original green line? And the answer to that is yes. They certainly appear parallel, and I can see that they both have the same slope here and here of -3. So yes, they're parallel. And does our blue line contain or pass through this point here? Yes, it does. And that's why it was so significant when I was counting off my slope and I got to that point there of that. All right, so that is where we're at. Okay, so we did that one right. Now, to be clear, the graph is really unnecessary. I wanted you guys to look at this and I wanted you to see that it works, but in most of the problems that we do, we're not going to be graphing. In fact, I'd kind of like to do this one without the graph. Maybe we'll come back and check it later. We'll see where we're at. Now, this gets a little bit more complicated. You will notice the difference right here because in example A, which we just finished, the equation that you were given, the line parallel to our line, was already in slope-intercept form. So it was really easy for us just to look at that and read the slope. Unfortunately here, no such luck, guys. The equation given to us, 2x minus 3y equals 12, well, that's in what's called standard form. Now, you don't need to know anything about standard form. I wasn't going to make you guys graph it or learn, slope formulas from it. But what's important right there, guys, is that we recognize that this line is currently not in slope-intercept form. And therefore, if we want to read the slope of that line, we've got to get it in slope-intercept form first. And to get an equation in slope-intercept form, you just have to remember the simple little phrase, solve for y. So that's what's going on right over here, guys. We need to solve this equation here for y. And when we get y by itself, then we'll be in business. Okay, what am I doing? I didn't leave myself a whole lot of room here. I would subtract that 2x. Let me cram this in here. I would subtract the 2x from both sides. Okay, and that would get us, I'm going to stick with the black right here, negative 3y is going to equal, and 12 minus 2x would be okay to write, but most people prefer it with the x term first, and that's not 2x minus 12. The 2x has to stay negative, the 12 has to stay positive. So that's the other way you would write that. And now to get y by itself, we would divide both sides by negative 3 on all terms, really. Each term individually gets divided by that number. So we're going to get y equals, that is a positive 2/3 x now, and then 12 divided by negative 3 is going to be a minus 4. So what we have right here, you guys, y equals 2/3 x minus 4, is the same line as this one right over here. It's just that now this one is in slope-intercept form. So what can we read here? The slope of this line is positive 2/3. Therefore, the slope of a line that is parallel to it, the parallel slope, would have to be the same slope as this line right here. I said I was going to do that in blue, messed that up twice now. The parallel slope would have to be 2/3 as well. And right there, everybody, we now know the slope of our new line. Furthermore, we also know a point that our new line has to pass through. 9, 5. So, knowing a point and knowing the slope, we are once again going to go to point-slope form. So I'll start here, and I'll change it by the end here. So point-slope form is going to be y minus your y coordinate, which is 5. So y minus 5 equals your slope right here is 2/3 times, in parentheses, the quantity of x minus the x coordinate, which is 9. So there's the equation in point slope, and now, again, the directions should have specified. They will on a quiz or a test. We want this in slope-intercept form. So the first thing we are going to do is distribute the 2/3 here, and we are going to get y minus 5 is equal to, so 2/3 times x is just 2/3 x, minus, and guys, remember the shortcut that I showed you here. Take your whole number, 9, divide it by the denominator, and then multiply by the numerator. 9 divided by 3 is 3. 3 times 2 is 6. Okay, so that's a minus 6 at the end of all that. And the last thing we need to do to get y by itself is add 5 on both sides. Those terms there cancel, and we're going to end up with our answer now in slope-intercept form of y is equal to 2/3 x, and a negative 6 plus 5 is going to give us a minus 1. And that, everybody, is the equation of the one and only line that's parallel to the original line, 2x minus 3y equals 12, and also contains the 0.95. I don't think I'm going to graph that one, everybody. I think we're going to move on, but that's the way we're running it here. So if you look at these two problems side by side, they're slightly different in the way that the original line is presented to you. A was already in slope-intercept form, B was in standard. But in both cases, the really important step is right here, okay, where we read the slope of the original line and then figured that our parallel line had to have the same slope. It took me more work to get that in the second example, but the same thing happened right here. We figured out the slope of the original line was 2/3 and knew that the slope of our parallel line had to be 2/3 also. So that's kind of the important takeaway there from what we just did. Okay, let's go back to a single page view and let's move on to this example right over here. All right, all right. And this one is the same but different, everybody, which is just a fun thing to say. We're now going to find the equation of the line, again, there's only one, parallel to x equals 6. That contains the point -7, 3. Now guys, there's a really, really easy way to do this problem. In fact, once you get the hang of it, boom, you're already going to be able to tell me the answer immediately, doing and showing no work whatsoever. But I got to show you the idea behind it. Okay, find the equation of the line parallel to the line x equals 6. Well, that's a weird one, everybody. This line, x equals 6, well, that's not in slope-intercept form. Okay, we can't solve that one for y because there is no y. So we need to go back to the table right at the very end of the notes there, everybody, from section 3.7, and remember that x equals a constant is the equation of a vertical line. So this is a vertical line, and this number here, 6, is what we called a. That is the x-intercept of this line. So from the origin, my x-intercept means I go 6 units right. 2, 4, 6, and there we go. And there is one and only one vertical line that passes through that point. So this line that I'm drawing right here in green is the original line here, x equals 6. And what we're looking to do now is come up with the equation of the only line that is parallel to the green line and passes through the point -7, 3. So let me plot that point. I'm going to go 1, 2, 3, 4, 5, 6, 7 units left and then 3 units up. So there is the point -7, 3. And we're trying to come up with the equation of the one and only line that passes through that blue point that is parallel to the green line. Well, let's go back to something we wrote in the very first slide right here, guys. All vertical lines are parallel. Another way of looking at that would be that any line that needs to be parallel to a vertical line, look at your red lines, everybody, to be parallel to a vertical line, you'd have to be vertical as well. So the answer to this question right here is going to be another vertical line. And again, there's only one vertical line that passes through -7, 3, and it looks like this. So I know that the line I'm looking for has to be vertical. Since it has to be vertical, the equation of that vertical line has to be x equals some constant. And that constant is what we called a. It's the x-intercept of your line, which would have to be this point right here. And as you might see already from the graph, where that line crosses the x-axis is at -7, which is exactly the same as the x-coordinate of any point located on that line. So guys, the answer to this problem is x equals -7. But with all of that work that I just did with graphing and thinking and whatnot, let me show you then quickly how you could have come up with this answer directly. Find the equation of a line parallel to x equals 6. So that's a vertical line, and parallel to a vertical line would be another vertical line. So it's x equals, and then all you need to do is read the x-coordinate of that point, and boom, you are done. Now that really wasn't a ton faster than what I did before, but that's kind of the quick way to go through that. All right, x equals -7 is our answer for that one. We'll come back and we'll talk a little bit more about a similar style of problem in a bit. Let me say again that horizontal and vertical lines should be the easiest problems that you guys deal with out there. However, people tend to struggle on these and do worse than they do on a lot of other problems that are out there because they're different than what we're normally used to seeing. Okay, guys, moving on now to the second half of our notes, we're now going to start talking about perpendicular lines. And this one is important here, everybody. Perpendicular lines have slopes that are opposite reciprocals. And that's a phrase that I should not just assume that you guys understand. So let's look at a couple of examples, okay? If you had a slope, let's say, of 3/4, we'll go with that one right there. The opposite reciprocal of 3/4. Opposite means, don't just think that opposite means negative. Opposite means that you change the sign of your number. So if your original number was positive, like this one here, its opposite reciprocal is going to be negative. But if the original number was negative, your opposite would be positive. Anyway, so opposite means change the sign, and reciprocal means flip the fraction. So 3 over 4 now gets flipped into 4 over 3. So everybody, the opposite reciprocal of 3/4 is negative 4/3. That's one example. What if we did something a little bit different? What if we had a slope of negative 2 over 5? Again, opposite means change the sign. So if we started with a negative, our opposite reciprocal is going to be positive, and we reciprocate the 2/5 to make a positive 5 over 2. Okay, so those are some examples of what opposite reciprocals look like. This is one that gets people all the time. What if your original slope was a whole number like 7? How do we take the opposite reciprocal of an integer? Well, for starters, that number is positive, so its opposite reciprocal would have to be negative. And to reciprocate a whole number, just remember that you can think of 7 as 7 over 1. And so when you flip 7 over 1, that is going to become 1/7. So that's an important one right there. Okay? The only other one that I think is really interesting and worth talking about is this slope right here. If you end up with, if you begin, I should say, with a slope of 0, and you've got to try to come up with the opposite reciprocal of that, if you do the method that I talked about doing on the last 3 problems, how do I turn 0 into a fraction? Well, it's 0 over 1, and then when I reciprocate that, it becomes 1 over 0. Hopefully, you guys know that this is a problem. You cannot have 0 in the denominator of a fraction. What that really means, another way to say that, guys, is you can't divide by 0. So when you try to divide by 0, that's when you end up with something that doesn't exist, or we would say that it is undefined. Okay? So 0, this is important, everybody, 0 is the one real number that does not have a reciprocal. Now, if we think about that in the context of what we're talking about here in section 3.8, a line that has a slope of 0, if we go back to 3.7, is a horizontal line. And if I look over to the right now, a line that has a slope that is undefined would be a vertical line. And we're talking here, everybody, about perpendicular lines. So I think it makes some sense to think that if your first line was horizontal and you wanted a line perpendicular to it, I think it makes sense that that second line would be vertical. So that is why this statement right here needs to be written, everybody. Any horizontal line and vertical line are perpendicular because technically their slopes are not opposite reciprocals because there is no opposite reciprocal of 0. Okay? All right, so let's knock out a few problems here and let's see how we do. Now you'll notice, guys, I did include a graph here on the bottom of this page, but it's way down at the bottom. I don't want to do this one graphically, but just to illustrate to you guys that we're right, at the end of this we'll go back and we'll graph both the original line and our new line to make sure visually that our new line does the two things that it needs to do. Okay, so the original line that we've been given is right here. Y is equal, let me do that in green, y is equal to 2x plus 5. And the great thing about that, everybody, it's in slope-intercept form, so we can just look at that and tell that the slope of that line is 2. And then from there, everybody, we are now trying to come up with the slope of a line that is perpendicular to that line. So I like to use this little notation here. Slope with a little subscript of perpendicular. So if your original slope is 2, your perpendicular slope is the opposite reciprocal of 2, which is going to be negative 1/2. And again, you can put that negative on the top or the bottom or out in front, but in my experience, up in the numerator is the easiest place to deal with it. So we now know the slope of the line that we're looking for. We also know a point that our line passes through. So if we know a slope and we know a point, we're going to begin originally by going to point-slope form, and here goes. Y minus your y coordinate. Well, minus -5 is going to show up as +5, equals your slope, which is negative 1/2, times x minus your x-coordinate, which is 4. So there's the equation of our new line in point slope form, and let's go ahead and let's distribute that negative 1/2 here, and let's eventually get it in slope intercept. Y plus 5 is equal to, this is a negative 1/2 x, and a negative times a negative is now a plus. 1/2 times 4 is a 2. And all we have left to do is subtract a 5 from both sides, like that, sure. And we're going to end up with our answer now, I hope, of y equals negative 1/2 x and then a minus 3. That should be our answer, guys. That should be the one and only line out there that's perpendicular to y equals 2x plus 5 and also contains or passes through the point 4, negative 5. So really, that's where we would quit, but I'm going to go ahead now and see if we've got this right. And I'm going to do that first by graphing the line 2x plus 5, and I'll do that in green here. Our y-intercept is 5, which is right there, and our slope of that line was 2, or 2 over 1, if you want to graph it. So up 2 and right 1. Almost right away, I run out of room on the graph going up 2, right 1, so I'll reverse it and go down 2, left 1, down 2, left 1, down 2, left 1, and that's probably good enough for what I'm trying to accomplish right here. So, whoa, there's the original line, and now we're going to try to graph this line and make sure it does the two things that we wanted. It looks like the y-intercept of this line is negative 3, so I go down 3 units and put a point right there. And our slope now is negative 1/2, which means I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, or reverse course here, and go up 1, left 2, up 1, left 2, up 1, left 2. Now I could do this as long as I needed to, everybody, but I think I've got the information that I actually needed. So let me go ahead and connect those blue collinear points. And there's the line that we came up with. And now as we go back and we read the problem again, two things should happen here. Number one, those two lines should be perpendicular. Now, we can't assume a right angle from a diagram, everybody, but in a lot of cases, you'll be able to tell if your answer is way off. Well, you know what? These two lines definitely intersect, and it looks close enough to being a right angle that I'm going to feel pretty good about my answer. So I don't know from the graph for a fact that they're perpendicular, but I do look at those two slopes there of 2 and negative 1/2, and I know they're opposite reciprocals, so I feel good about this. The other thing is that our blue line had to pass through the point 4, negative 5. So if I go back to the graph and I think about 4 and then 1, 2, 3, 4, 5 down, that right there is the point 4, negative 5. And sure enough, this is the importance of using that slope multiple times. Our blue line did pass through that point of 4, negative 5. So I don't know about you, I feel pretty darn good about that answer that we just came up with, everybody, because it does both of the things that we were looking for. So yay, everybody's happy. All right, let's do another one here, example B. And like example B in part 1 of our notes, this is a little bit more complicated than what we were doing before. Okay? We need to find the equation of the line perpendicular to this containing that particular point. Well, the only thing tougher about this problem than the last is because, once again, the line was given to us in standard form, not in slope-intercept. And it's harder to read the slope out of the line in standard form than slope-intercept. So just like before, what we need to do here, guys, is we need to solve this line right here for y if it wasn't done already for us. So again, I'm going to subtract a 5x from both sides here. Those are going to cancel, and we are going to get 3y is equal to a negative 5x plus 12. And then we're going to divide all three terms here by 3. And that is going to get us y equals, now guys, let's not panic, and you certainly don't want to reach for your calculator here. Negative 5 doesn't divide evenly by 3. So what do I write? Well, this is the entire reason that fractions were developed, everybody. Negative 5 divided by 3 can't be simplified, so we just leave its quotient as negative 5/3. Negative 5/3 means negative 5 divided by 3. I like to put the x at the end of that and then a plus 4. Okay, so that, everybody, is another way of writing the original equation. And the whole point of doing this is that we now needed to know the slope of that line right there, which is -5/3. Well, if that's our slope, everybody, and we are looking for a line perpendicular to that, the slope of a line perpendicular to this line right here would be the opposite reciprocal of -5/3. Flip the fraction, change the sign, and we're going to end up with 3/5 for the slope of our new line, which is perpendicular to their line. So there's the slope. Once again, we were given the point right here, so now once more we are going to go to point slope form for our line. So point slope form is going to equal, here we go, it's going to be y minus the y coordinate of your point, which is -1. Well, minus -1 is a +1. That equals your slope, which is 3/5, times x minus the x coordinate, which is 5. So there it is in point slope. Let's put this in slope-intercept now, because that's what the directions are probably going to ask for. Y plus 1 will equal, this is 3/5 x, minus, and let's do this trick again, guys, whole number, 5, divided by the bottom, 5. So 5 divided by 5 is 1, times the numerator of 3, that makes a 3 there. So that's where we're at, and the last step now is to subtract 1 from both sides. And we are going to get y is equal to, this is a 3/5 x and a -4. All right, and that is the equation of the line that we were looking for. I'm not going to bother graphing this one, guys, because I'm almost out of time, and I've got one more problem to do with you before we're done. All right, so let's move on to C here. Find the equation of the line perpendicular now to x equals 7 that contains the point -3, 4. All right, and you might already see what's going on here. Yet again, x equals 7, let's talk about what happens when we give a vertical, or when we are given a vertical line right here. We're trying to come up with the equation of a line perpendicular to a vertical line. So you might already know where this is going. The line x equals 7 is this one right over here. You know what? I've always been drawing the original line in green, so let me do that. There we go. So that's x equals 7. And we're looking for the equation of the one and only line that's perpendicular to that line and passes through the point -3, -4, which is located right here. -3, -4. There is only one line that passes through the blue point that's perpendicular to that green line. So let's talk about what that looks like. This line here is vertical. Therefore, the perpendicular line to a vertical line has to be horizontal. So we need to understand that basic idea now. If we want a line perpendicular to a vertical line, it's got to be horizontal. And for that reason then, the equation of a horizontal line is always going to be y equals some constant. Now that constant there, what we wrote down in 3.7, is b. It's the y-intercept of your line. So, again, I can kind of draw already what's going on. I need to draw the one and only line that passes through -3, -4 that's horizontal. It looks like this. Okay? And the number that I need right here, guys, is b, which is the y-intercept of that particular horizontal line there, and that is going to be -4. That's your answer here, guys. Y equals -4, which again you'll notice is the y-coordinate of this particular point that it passes through. So let me say again that these horizontal and vertical lines here are a little bit, people find them tricky because they're different, but they're actually the fastest and easiest out of all of the problems that we're going to be doing. All right, guys, that is a wrap on section 3.8, so let's give that homework a try and let me know if you guys have questions with it. Good luck.